Hello YouTubers, today I'm going to be going over the Chinese cheap spot welder. It's actually a nice spot welder, especially after you upgrade the tips on here. But we got this battery here. I purchased this one off Amazon, pretty cheap, like 40 bucks. It has a little meter that comes with it, which is pretty nice and handy. So we plug that in. Doesn't really got a socket for it. You kind of gotta plug it in here. Little connector like that. So I silenced the beeping noise because it's really piercing. So that's telling our voltage on each cell. 3, then all voltage 12.4. So we'll set that to the side. So what I want to do is, what I did with this, upgrading this spot welder for the terminals and everything. Obviously I added a fan. This is a fan that cools and blows out all different directions. It's pretty nice. This is out of MacBook right here. 2, I got a 18650 cell holder here, positive and negative. This is for the fan itself. I tried some voltages off here. I didn't really want to take away from the voltages because I got this keyed in where it works. It doesn't blow the MOSFETs. A lot of people run into the issue where they're blowing the MOSFETs. We'll take this apart and take a look at it. But, so what I did is just a little like hot glue, hot snot, whatever you want to call it. The actual battery right here, these are terminals to the battery for the fan that supplies power to the fan itself. It's out of an older MacBook. They kick with some, especially with the battery fully charged. So just basically hot glued that right there. Also, I did add a diode in series with the battery, so it can't kick back so much to the battery. So I used a high-powered TV diode, just scrapping some boards. I have lots of parts. So I did that. 2, if we look at what the specs on this thing is, it says, 3S, 40 to 60. So we got, this is a 5,000 milliamp. And this is a LiPo battery. Basically it tells you to use a different battery, but the same principle. 40 to 70. So we got 60 here. Plus you got your 12 volts. Needs 12 volts. This is reading at all 12.4. So we got our 12 volts when this is charged. So you don't want to drop this battery down too low. But using other batteries, trying other batteries too, you'll fry this, no problem. I tried it with my other battery. I did not blow this. And I did a first test just to make sure it didn't blow with my other battery. But when I did this battery right here, you don't have that much of an issue with this one because it can handle a lot of power. But either having too much power or too little power is going to blow this. So let me say that again. Too little, much power, and too high power is going to blow it. And by doing a scope reading, I blew a couple of these MOSFETs. I got a reel of them. And I replaced a couple of them, tried it. And you can see on the scope it has a dip where it just drops. And I was thinking that it is. It's holding the controller open even before doing scoping. And I thought about that. I was like, hey, it's not holding the controller open enough where it dies out and loses power from the controller unit. Therefore, it keeps these open too long, which fries them and cracks them, blows them, whatever you want to call it. So that's my experience with this is a cheap spot welder, but it works awesome. I like how you could just connect the two tabs together and then it beeps 3 times and then it spot welds. I mean, yes, it takes a little longer to spot weld and stuff like that, but honestly, I blew it a couple times, tried different designs with it and everything. So basically, I just put a capacitor in line with the controller IC to give it a little bit more of a spunk so it doesn't dip down so much. So we're going to take this top cover off so I can go over this. One thing before I plug in the battery and everything, I want to show you how long this stays powered up for too. So since we did this mod, if you had this battery and didn't do this mod, you'd see your controller unit die instantly after powering it up. I could actually disconnect this from the battery and this will still stay powered up. I'll show you that right now. Alright. So here, I'm going to plug it in. Got the switch off. Might see a little spark here. Sometimes. Alright, so we're going to power this up. It's going to beep 3 times. Or whatever. Alright, so it's powered up. We got a display there, right? It's saying we got 12.4 volts. This is reading 12.4. So pretty accurate. See, that's the cell groups. 12.4. And then we have our reading right here. Now, I'm going to shut this off. You're going to see the capacity level that's stored in this. I disconnected the battery. Now the controller is still thinking there's electricity, which gives it that extra spunk so it doesn't fry the MOSFETs. Actually beeps everything. There we go. See, we're connected. It's just running off the capacity of the capacitors. There it goes. It just died. So it's running off both these capacitors. This little mod. I'm going to show you what I did. So you could test yours, like plug it in and see if it stays charged up like that. It's not going to. So we got this totally disconnected. You gotta watch yourself with this capacitor here. That's a high charge capacitor. But since we kind of discharged it, it should be good. We're going to wiggle this off. Control unit. And I'm going to show you the control unit under side camera microscope. So you can see I beefed up the plane area right here to absorb some of the heat from these MOSFETs. 2 also over here. And then I beefed up the bars right here with a couple copper bars and some copper here. A lot of solder. So I added a lot of weight to this, which can dissipate a lot of heat, taking it out of the battery terminals. Because you use this enough, you're going to get these battery terminals hot enough. And to not spike the battery back, that's why I use a diode. So let's go to the side camera here. So that's basically what I did to beef it up. Lots of solder and copper. Plus I protected the capacitor from discharging. Obviously, if you would have a capacitor straight on a board instead of bent over like that, especially a capacitor at that level. So by adding that, and here's the specs that you're supposed to use. 3S, 40 to 70, and 5,000. So now I'm going to do measurements of the stuff I'm going to just test right now, just to show you how beefy it is now. Before doing this mod stuff right here, even doing this, these blew a couple times. I had to replace them. So figuring that the controller is not staying open long enough and losing power, therefore basically it loses power and it just like keeps them open and then fries them. And that's basically what's happening. So I have a capacitor here. I put this capacitor in here. It's a 16 volt by 560 UF. You could go a little bit higher on the UF if you want. I would kind of stay around the 650s and probably just a little bit lower. Oop, I hit my camera there. So it's basically sending power right here, going over here to this circuitry over here, all the way to these resistors, going to the controller chip here. So it's basically supplying the controller chip with enough power. So when you drain by using a no good battery that's not powerful enough, or having too much of a powerful battery can cause it too. But most of the time it's because of not having enough power in the battery to be able to do that spark. But in theory, there should be a capacitor inlay with this controller to keep this controller chip open a lot longer so it doesn't short out the MOSFETs, if you guys get what I'm saying about that. Maybe this will help a lot of people out, because there's probably a lot of people that buy this. They're like, hey, what's going on? And it blows first time they try it. So do this mod before it blows. And so basically what I did, we'll go under a microscope with this. Grab a pair of tweezers here. Got some around here somewhere, you know. So I put some heat shrink on here. You know, it's ghetto fabulous, but it works. So basically, I solder to here, which is the negative right here. So this is a negative. You guys can see that on the microscope. That's a negative. That's a positive. Right there. But negative, so we soldered the negative of the capacitor, which is the dotted lines right here. Then we did the positive over here on this side. So the positive over here, that sends that extra voltage to the controller chip. So just basically sending extra power to there so it doesn't shut off and doesn't blow. Then I just added a little bit of hot glue right here. This is kind of a somewhat thin capacitor. It fits there. It's not going to touch the bottom of it. So you're going to have to figure out what type of capacitor you're going to use. Like I said, I want to go any lower than like 430 or something like that, or I would try to stick with this number, or like, 6 something. I wouldn't really go too higher than that. So basically that's the modification I did there. And that stops the MOSFETs from blowing, believe it or not. And then I shielded, obviously, the main capacitor there. So that has no reason to short out. Then with the fan cooling system, with the 18650, you can't beat it. So we can put this back on here. And then I can show you it working. Where it's not blowing nothing. So I tried it a couple times, all different. I tried even the copper stuff, everything, some diodes in series and everything. The diodes didn't work. I just knew the controller was being pulled down and losing voltage. Which, if you lose your voltage on your controller, it's just gonna mess things up. That's exactly what it did. Alright, so I'm gonna plug it in. I'll show you. So we got our leads over here. I'm gonna plug this in. We're gonna put a battery in. Got us a LG. So we got the fan. We got fan spin. So we got that plugged in. We got our voltage. Here we go for all. 13.4. So we turn this on, it should say 13.4. I gotta silence that beep thing. I always do that with some hot glue. That's annoying. Especially if you're doing a lot of spot welds too. So now we got that powered up. Kind of want to show you. This says you're supposed to use what is it? Trying to think. What the heck is it? Alright. So you're supposed to use 0.1 0.12 millimeter of spot welding material, which this right here. So I'm gonna test this right here. We're gonna turn on. The battery's almost dead, so it's gonna be hard to see. Let's see. Let's reset. Alright. Man. So I'm doing 2.7, 2.8, right around there. Let's try a different piece. That's with tape. Hold on. There's tape on there. So we're doing 0.21. That's what we're doing. Which is way over that. So I got this bumped up to 50, and I got it set to automatic. So we're going to do even more what it's recommended now. Probably with the battery terminals here, I'm probably going to come out with a different mod with a third fan system onto basically a heat sink to be able to take the heat away from the wire system with copper heatsink and a fan system. Basically out of a used laptop or something. Figure out something. I'm not done with it yet. And we got some glue here, so I don't know how that's going to play in factor with it. We're just going to use this as a test piece right here. Because it's thicker normally than what it's rated for. So let's go to the side camera so we can capture this. Got everything plugged in. Side camera here. I wonder if I can get the sparks under microscope and everything too. That's going to be pretty cool. So we're looking at it. It's dropping in voltage for some reason. Alright, so that's weird. I don't know if you guys are viewing that right there. You can see the input voltage. I'm not even moving it. 12.4. So I must got a loose wire somewhere. Let's see. Move this around. It's not there. I swore it was dropping on voltage. See, there it goes. It's dropping right there. See it? And then it's going to pick back up. It's dropping low. There it goes. It just shut off. So maybe it's just reading the system. That is weird. So we got it set to auto. We're not going to worry about that. So the computer system is saying that we're dropping our voltage. And it's not a loose connection. It's just the computer system. Like, I'm wiggling the wires. These are all solid connections. There it goes, dropping. I don't know, that's weird. Alright, so we got that there. Let's spot weld this. So on the battery it's saying 12.4, which is saying 12.4 over there, as you can see. Let's see if I get this on camera. There you go. Definitely melted it. You can smell it. And you know you want to use the fume extractor. So we'll turn that on. Fume extractor. You don't want to breathe that stuff in too. We're going to do another one right here. Let's say right there. See if I get that on camera more for you guys. Alright, there we go. Looks pretty good to me. Everything's cool to the touch. This is blasting. I don't know, let me grab a little piece of tissue. Show you how this is blasting. Turn off my fume extractor. Oops, wrong light. Wrong switch. See that? That thing is like cooling that thing too. All over. Even when I go back here. So, pretty cool. Let's take a look at this. You can see definitely spot welded it. And we had some tape or whatever, some glue type stuff on there. Let's take a closer look at those spot welds. Obviously you're gonna want the ends completely flat if you're gonna be doing batteries, but and it didn't blow it like how it's designed to blow when you first get it out of the box. So I'm trying to tear this apart. I can't tear it apart. Come on. Yeah, I don't know, man. I might have to grab some pair of pliers or something. There we go. Man, it was on there. Well, I can't rip that. I'm gonna have to grab a pair of pliers. I'll just grab this and my other snips. Yeah, it's on there. I'm pulling. It's just gonna rip. It's not even gonna. Pretty crazy for a cheap spot welder after doing a little bit of modifications. And there's a lot of other forms out there too that other people are doing, you know, with it. Pretty crazy stuff too. Like doing a lot of diodes in series and stuff like that. That's why I put a diode on the battery cable itself, so it can't send voltage back to the battery at a higher rate. Let's try this one more time. And then I'll end it on that note. Let's try doing right there. Let's try welding it there. I got this turned up high because, I mean, like 50%. The reason why is because I'm using like way thicker stuff that it's not even designed for. You can see it sparked big time. So that's a little high, but I'm putting a lot of force on there too. I think it's probably gonna be hot. Yeah, it's hot. That's for sure. Obviously that's a little too high, but yeah, I'm not gonna be able to tear that apart. You're gonna need tweezers and stuff. I mean, it's on there. Yeah, I'm not gonna get that off. And you know, it matters how much pressure you put on there. Look at that. So it's literally ripping it. Before breaking the spot welds. You can see how that just spot welded it. Those two ends there. So, pretty crazy. It works. Cheap. Spot welder. I really didn't want to give up on it. I had some type of faith in it. But after blowing those MOSFETs like that, and they're pretty expensive, they're not really cheap, especially when somebody is expecting to do spot welding, especially in different countries, and you know they can't afford buying extra parts and stuff like that. But I just did it as a little side hobby. I got a lot of battery packs that I want to build and stuff like that, and I built my e-bike battery pack, which I did a whole different way. But I was interested in getting this going, and I did. There's other people posting out some other videos out there doing it their own way and modifying it, but knowing that the controller chip needs that little extra spike of power so it doesn't die, keeping these MOSFETs open where it just blows them, you know, creating a short. So I hope you guys liked the video. If you guys get a chance, if this video helped you, give this video a thumbs up. Also, if you guys haven't subscribed to my channel, hit that subscribe button. And as always, thanks for watching.